Hey guys, let me get set up here for a sec. Okay, so guys, we're going to continue our discussion through the operations of functions unit. Our topic today is called composition of functions, and this is the last topic of chapter 10, and then we're going to move on to the next chapter after that. All right, so composition of functions. So really what composition of functions is all about is substitution of functions. Sorry guys, just got a brand new laptop today and it's going to take me a while to figure out how to work this one a bit better. Okay, substitution of functions is what composition of functions is all about. So example one, on the graph we have two functions. We have this is going to be a radical function or a square root function for f of x, and then we have a linear function for g of x over here. First question, very similar to what we did at the beginning. All we're doing is f at 10. And what this means is when x equals 10, y equals 1. And we're looking on the f function because it's f of 10. So this equals 1. Okay. Next one, let's go to g at 1. So now we're looking at the red function here. So when x equals 1, g is equal to -1. Okay, so we start talking about substitution of functions or composition of functions. This is what we're talking about in example 1c. So here we're asked to figure out what f of 10 is on the inside. So, and we saw before, f of 10 is equal to 1, right? So what we're going to do is we're going to make a substitution, and this number of 1 is going to go into f of 10. So this is really the same thing as g of 1, because f of 10 equals 1. So now it's a function g being evaluated at 1. And we saw that in the previous example. When x equals 1, g equals -1. All right, so this is kind of the idea for the questions we're going to look at over here. So what we saw over here, where we're taking one function inside of another function, this is what we call function composition. So this notation over here, so this is like some function f being put into some function g, can be written in new notation like this, as g of f of x, like this. Okay, so this is an open circle, which means g composed of f of x over here. So if you look at example D, it says f composed of g of 0. This means the same thing as f of g at 0. Okay, so what I want to do first is, well, let's figure out what g of 0 equals. So if I look at my g function, my red linear function here, when x equals 0, my y value is -2. So we know that, put this off to the side here, g of 0 equals -2. So this is the same thing as f of -2. So now we want to look at our f function, which is the blue radical function here. So this says when x equals -2, y equals 3. And we're looking at the blue function for this one. So this answer is 3. Okay. All right. G composed of f of -2. So this means g of f at -2. Okay. F at -2 is 3. So this is the same thing as g of 3. Okay. So now when x equals 3, y equals 1. All right, and that's how this guy works. Look in example F. We have g composed of g of 3. So this is g of 3 like this. So we look at our g function. When x equals 3, y equals 1. So that means that g of 3, so I'm going to go like this guy over here, is equal to 1. So this is now g of 1. And now if I look at when x equals 1, g of 1 is -1. Example G, f of negative 2. So this means f composed of negative 2, like this. F at negative 2 is 3. And now it's f at 3. Okay, so when x equals 3, y equals 2. All right, last one looks longer, and it definitely is, but we want G composed of f at negative 5. On the question like this, we're going to start on the inside and work out. So what's f at negative 5? F at negative 5 is 4. So we know that this value here is 4. G of 4. All right, so now we look when G equals 4. We look at the red function. We know that y equals 2. So G of 4 is equal to 2. So now we have G of 2. All we did was replace G of 4 with 2. So now we look when x equals 2, y equals 0. So G of 2 is 0. Okay, so that's how this guy works over there. So hopefully you get that the idea for these questions is you're doing the inside part first. Okay, so figure out what that part is, and then evaluate the outside parts afterwards. All right. Example 2, so similar idea, except now we're dealing with equations instead of points on a graph, okay? So for the first one, A, we have f of g of x, and this means f of g of x here. So what this means is that we have our g function here is going to be substituted into the x of f of x. So this is going to equal x minus 3 squared minus 9. So all we're doing is we're taking the g function here and putting it into the x of f here, right? So now since it's x squared, it becomes x minus 3 squared. This minus 9 stays with this minus 9 over here. Similar idea over here, except we're substituting in the reverse direction now. Instead of going g into f, we're going f into g. Sorry, guys, trying to figure out what I did here. Okay, so we have this is g of f of x. Okay, so we're taking our f function, which is x squared minus 9. I'm going to put a little circle around this guy, and this can get substituted into g right here. Okay, so this is going to equal x squared minus 9 minus 3. Now I can just simplify this a bit. Negative 9 minus 3 is the same thing as negative 12. X squared minus 12. Okay. C, h of f of x. That means we're taking our f function into h. So this is going to be the square root of x squared minus 9, okay? We can't simplify this any further because of this minus over here, so it's not like we can just square root this x squared and square root the 9. We're not allowed to do that because of this minus over here. So we're kind of following the radical rules that we learned last year. We're just going to leave this like this. Done. All right, this one, f of h of x. So this means that we're going, our h function here goes into f is the square root of x squared, because it's this squared over here, minus 9. Now, square root of x squared is x minus 9. So if you square a square root, the square root sign just disappears. All right. So this is how the same example works, just with equations instead. Okay. Example 3, bit of a trickier question over here. So we have, so what this is saying is f of g of x equals, so this is our h of x. Well, this equals x cubed minus 7. So really what we have here is we have f of x, which is x minus 7, and we have some function g of x over here. Okay, so we need to figure out what is this g of x function here going to be. So the idea is like we're taking something and we're going to plug it into this x over here, and we want this to be the result over here. Okay, so what's that have to be? Well, I think hopefully you can see that in order for this to work, g of x has to be x cubed, because if I take this value x cubed and sub it into this x over here, this x will become x cubed minus 7. Okay, so this is what g of x is going to be. Similar question over here. We have h equals f of g of x over here. So the easiest way I'm going to explain this question is I'm going to show you the answer, and then just hopefully you can see why this answer makes sense. So if I can say, remember we're taking g and putting it into f. I'm going to say that f of x is x squared plus 4x minus 5, and then g of x is going to equal x minus 1. So what would happen if I put this function into this function over here? Well, this x minus 1 would go in for this x, and we'd have x minus 1 squared here. The x minus 1 would go in for this x over here, and I'd have plus 4 x minus 1, and this minus 5 stays independent afterwards like that. Make sense? Similarly, for the next example here, I'm going to suggest that we make f of x equal square root of x plus x. Okay, and then I'm going to say g of x equals x cubed minus 1. So if I take this and plug it into this x and this x over here, well, this x would become square root of x cubed minus 1, like it is over here. And this x we replace with x cubed minus 1, which is x cubed minus 1 over here. Okay, so this question over here, it takes a few examples to kind of wrap your head around, but really what we're doing is we're kind of like, we're unsubstituting and kind of figure out how that's going to work. Okay, so given the graph below, determine the x-intercept of g of f of x. Okay, another tricky question over here. We have g of f of x, like that. Okay, so when we're talking about x-intercepts, we want the y to equal 0, because x-intercepts happen when y equals 0. Okay, now if you look at over here, I think when x equals 2, y is going to equal 0. Okay, now it's a little bit tricky over here because like this is the y-intercept for g of x, but we want the y-intercept, sorry, this is the x-intercept of g of x, but we want the x-intercept of h of x, which is equal to g of f of x, like this. So what do you think of like what value of x is going to turn this value here into 0? Well, like we saw, what makes g 0? If x equals 2, that's going to work, but unfortunately it's not going to work with this, because if I go x equals 2, the way that this function says of g composed of f of x, well, that means the f of x is inside of here. If I put in x equals 2, well, that means y equals 7. And then if I take that 7, put into g, well, it's going to be way, this function is going to be way up over here. So definitely not an x-intercept, okay? But if I make x equal to -3, so if I say if x equals 3, then f of x equals, and sorry, this is f of x equals negative 3. My mistake. Then f of x, so let me back up. Then f of negative 3 equals 2, right? So if I'm, again, remember, I'm looking at the inside function first. So if x equals 3, that means y equals 2, right? And then what I'm doing is I'm taking this 2 and putting it into the g function. So the g function is this guy over here. Well, if x equals 2, y is going to equal 0, right? So let's back up this up. What is h of negative 3? Well, that equals g of f of negative 3. And where it said f at negative 3 is 2, which is equal to g of 2. And g of 2 equals 0. So therefore, and these 3 dots always mean the word therefore, negative 3 is the x-intercept. Okay, and that's how this guy's going to work over here. Okay, next example. Given the functions f of x is x squared, g of x equals square root of x, determine the domain of f of x. So if I'm looking at this guy over here, just x squared, there are no restrictions on x. I can put in any negative number, any positive number. I can put in any whole number, any natural number, any rational number, any irrational number, it doesn't matter. So my domain is going to be from negative infinity to positive infinity. G of x. For a square root function, we're not allowed to take the square root of a negative number. Therefore, our domain is going to be from 0 to infinity. Okay, so this is how we write positive numbers. It goes from 0 to infinity. Part C says, write the simplified equation of f composed of g and g composed of f. Okay, so let's do the first one. F composed of g means we're taking g and putting it into f is equal to the square root of x squared. Okay, so the square root of x is going in for x. We're squaring it, which just becomes x. If I go g composed of f of x, then I have g composed of f of x like this, and that means that f is going into g. So it's going to equal the square root of x squared. Well, if I take a square root as in the squared, I'm just going to get x. So the point I'm trying to get is, at the end, our answer is both going to be x, okay? Now, what's slightly different over here is, I'm going to say, is how we got to this answer of x. In this case, in the first one, we took a square root and squared it, okay? In the second one, we took something which was on the inside, which was squared, and then we square rooted it, and we got the same answer. So why is this? Well, let's say that, yes, the answers are the same for now, but we need to go and take a look at the domain and range of these guys, okay? If we look at the domain of the inside part over here, okay? Well, the domain of the inside part was square root of x, okay? So that's what our g function is. We definitely have a restricted domain here. It was a square, it was only from 0 to infinity. Well, if this part over here can only be from 0 to infinity, it's going to have to be the same thing for this guy over here. So that means for this domain, it's going to be from 0 to infinity. But whereas this one, the rule is we're not allowed to square root a negative number. Well, this is never going to be a negative number here, because in this case, I'm allowed to put in a negative number. Say if I go like a negative 3 in for x, well, negative 3 squared is positive 9. And if I square root that positive 9, I'm going to get a positive 3. Okay, so in other words, if x equals negative 3, y is going to equal positive 3 for this guy over here. So in this case, our domain is going to be, my mistake, there should be a round bracket here, from negative infinity to positive infinity, like that. Okay, so we'll talk about the range later on, but I think it's going to make more sense if I do this one on a calculator. So I'm going to post another video in a second, and I'm going to show how to be able to do these type of questions with your graphing calculators and how those ones work as well. Okay, guys, hope this makes sense, and I will see you in the next video.